Hello, ninth class. Today we are going to study about Charles' law. This law was given by Jack Charles in 1787, and he was studying the relationship between volume of a gas to the temperature. And experimentally, he found out that whenever there was increase in temperature of a gas, or there was a decrease in temperature of a gas, the gas was expanding or contracting by 1/27th of its 1 by 273 of its volume. Now, he formed a law and said that the pressure remaining constant, the volume of a given mass of a dry gas increase or decrease by 1 by 273 of its volume at 0 degree for each 1 degree increase or decrease in temperature respectively. Then he had given expression also for that. Let V0 be the fixed volume of a gas, and at that time the temperature be 0 degree. Now let V be its volume when the temperature increase, and the new temperature is T degree Celsius, and keeping the pressure constant. Then according to the law, what he said, that V is the new volume is equal to the initial volume plus increase in the volume V0 upon 273 into T. Now if we rearrange it, we will get V0 273 plus T upon 273. If we rearrange this whole thing, we will get this thing. Now if we take V0 upon 273, you find V0 upon 273 for a given temperature is always constant, V upon 273. So if it is a constant, we can substitute it by taking K, constant value. So what we get, V is equal to K into T. And if we remove the sign of equality, we putting the sign of proportionality, we get that volume is directly proportional to temperature. Or we can rearrange that V upon T is equal to K. So this is a Charles' law. What now? It's new generalization, that volume is directly that volume of a given mass of a dry gas is directly proportional to its absolute Kelvin temperature if pressure is kept constant. So now we will see, according like we have done a relationship in Boyle's law also, that let V1 be the volume, and at that time T1 will be the temperature. Similarly, V2 another volume is there, and T2 is at another temperature for same gas. So V1 is directly proportional to T1, will become V1 is equal to KT, or V upon T is equal to K. Similarly, for V2 directly proportional to T2, and V2 upon T2 is equal to K. And as both of them are constant, we can relate them, that V1 upon T1 is equal to V2 upon T2. They are constant, K at constant pressure. This equation is known as Charles' law equation. Now according to this, what we got, if a temperature is doubled, the volume should be doubled. If the temperature is reduced by half, the volume would also be reduced by half. Now let us do the graphical representation. When we are drawing a graph between volume and temperature, we see a straight line. It's an isobar, means it's a graph or a process in which pressure is constant. We call them isobars. So it's a volume temperature relationship. What it says, it's a straight line passing through the volume and meeting at minus 273 degree. And minus 273 degree is supposed to be a minimum temperature which it has not been attained. It is hypothetical temperature which can be attained, minimum in minus. Okay, now if we talk about explanation of Charles' law in term of molecular motion, said that there are large number of molecules, or there are large number of gas particles which are having certain kinetic energy, and which is directly related to temperature. Kinetic energy of a gas particle is directly related to temperature. If we increase the temperature, the molecules will start moving and colliding with the wall with a greater force. If I decrease the temperature, the kinetic energy of these gas particles will also decrease. So now what will happen? Kinetic energy is what? Energy by virtue of its motion. So when I increase or decrease the temperature, the molecules will strike the wall of the container. If I am increasing, they will be striking more frequently and vigorously. If I decrease, their vigorousness or their frequently, it will decrease. So when they are striking more vigorously, there is going to be increase in the volume because pressure will be kept constant. At the same time, if I decrease, then what will happen? The striking speed of the molecule will also decrease in pressure, and as pressure is constant, so it will be directly relating to temperature by decreasing the volume. Okay, now coming to significance of Charles' law. Volume of given mass of a gas is directly proportional to its temperature. Hence, density decrease with increase in temperature. When I am increasing the temperature, the volume will increase, the molecules will move apart from each other. Hence, there will be reduction in the density in the given per unit area. If I decrease the temperature, the molecules will come near to each other as the volume is decreasing. So, there will be increase in the density. So, density increase or decrease depend upon the temperature increase and decrease. This is the reason why hot air balloon, when hot air is filled in the balloons used for meteorological purpose. Now